Hello. What we have here is an architect's design for a warehouse, which is interesting in that instead of utilizing some deep eye sections, the framing is done using trusses. This original design has some items of note in that the trusses are slightly tapering and that some of the noding is a little bit off. For example, where the column truss connects to the rafter truss and at the haunch. This concept is to be designed and optimized, and a Grasshopper Karamba workflow is ideal for something like this to explore options and to understand the structural behavior better. Whilst it is tempting to start jumping into a definition that parameterizes the truss elements, I prefer to take it back to the first principles and review the behavior of a simple, flat portal frame, then layer on some complexity to review structural behavior. Okay, let's consider a portal frame on the two load cases, a simple UDL and a lateral point load. Here, you get your classic bending moment diagrams. Now, we can consider the effect of the rafter pitch and how the ridge affects things. At extreme angles, the moment at the ridge goes into negative hogging, and the single sagging moment across the span develops into a double hump. At a pitch of only 2 degrees, set for sufficient roof drainage purposes, the effect is nominal, and the maximum sagging moment is not reduced significantly. The corner moments are high, of course, and we can explore the effects of a haunch crudely by adding a truss element in the corner. This reduces the max moment in the rafter, and the high moment is transformed into a push-pull within the haunch. The increased stiffness in the corner reduces deflection. And this is what changing the stick model to a truss can do. The bending in the stick elements can be transformed into axial pull pushes in trusses, and some benefits can be realized, such as reduction in self-weight and increased stiffness with greater depth. For fabrication considerations, it is better to try and keep the trusses straight rather than tapered. So in Grasshopper, we can control the haunch depth and the length of a transitional tapered truss in the same way we controlled the haunch position in the stick model. Beyond the tapered truss, we maintain a straight regular truss. Here, we can now perform quick comparisons between a truss model and a beam model, showing how similar or lesser maximum displacements can be achieved for significantly less mass. Let me know your thoughts and drop a comment down below. Thanks for watching.